Hi, and welcome to another video on object-oriented programming in C#. With me, Marinas Toman. Okay, so in this second part of this video, we're going to look at relationships between classes when we're denoting class relationships in UML class diagrams. So UML is not just about pretty pictures. If used correctly, UML precisely conveys how code should be implemented from diagrams. So this is one of the benefits, of us using class diagrams. Once we draw up our system, then we can just, code straight from the diagram. It makes coding up our whole system a lot easier. It makes it so straightforward. If precisely interpreted, the implemented code will correctly reflect the intent of the designer. So we can just translate exactly what the design is on the class diagram straight over to our code. And if the design is good, then the code's going to be good. The relationships between, the different objects. So some of the objects you can see here are some of the relationships between different classes are denoted here. But really what we want to look at is kind of association and inheritance. Just we're only going to look at the first two really in this video. So inheritance, or generalization as it's sometimes known, this is a taxonomic relationship between a more general classifier and a more specific classifier. So basically you go between a general class, and then whenever it's in an inheritance kind of structure, whenever a class is inheriting from a parent class, you always want to be going more specific. So a child will be more specific than a parent. Each instance of the specific classifier is also an indirect instance of the general class. So thus the specific class inherits the features of a more general class. This represents an is-a relationship. An abstract class name is shown in italics. So if it's an abstract class, the parent class is an abstract class, it's typically in italics. And then subclass 1 and subclass 2 are specializations of superclass in this example here. So with this kind of hollow arrow, this triangle, this is what denotes that this is a parent class. So a superclass, as it's sometimes known, and then these are children classes or subclasses. Okay, so these are specific types of this class. So this shows, this is a general inheritance hierarchy. So the relationship is displayed as a solid line with a hollow arrowhead that points from the child element to the parent element. Okay, so it points up to the parent. So you're basically saying this class comes from here. It inherits everything from here. So the figure below shows inheritance example with two styles. Although the connectors are drawn differently, they're basically it's equivalent. It's the same as this notation, whichever you prefer. These are both, basically the same. Sometimes this will be nice and tidier, but sometimes you're not so lucky to get all of your classes that are inherited directly from a base class directly beside each other. So that's why this is basically allowed. So this each one of them can have their own direct link back to the parent class. So associations, that's inheritance. Pretty easy, just these, just a solid line with a hollow arrow point and pointing up to the parent class. So associations are relationships between classes in a UML class diagram. They're represented by a solid line between classes. Associations are typically named using a verb or verb phrase which reflects the real world problem domain. So let's have a look here. Simple association, a structural link between two peer classes. So there's an association between class 1 and class 2. You can see here. The figure below shows an example of simple association. So this is an association that connects between these. So you can see the control and the boundary. The relationship is displayed as a solid line connecting two classes. So this is just, when classes are associated with each other, we just put a solid line between them. And then, sometimes you'll see this more. This will more be in. You might have it in your class diagrams, but a lot of the time, your cardinality is basically the how basically the number of your relationships. So let's say you have two classes that are related, and one like a customer class and an order class. So one customer can make many orders, so that would be a one-to-many cardinality. That's or you could have many-to-many, or just one-to-one. So cardinality is basically your association is the solid line, is your relationship, and then cardinality is just your numbers. Okay, so you can see the different ones here between, this is exactly 1, so that would be 1. The other class over here, if it was 1-to-1, you would have a 1 there as well. If it was 0-to-1 on this side, 0-to-1, because the thing about relationships is they go both ways. The relationships between classes and objects are always two-way relationships normally. So yeah, sometimes cardinality is good to know, just for when you're reading other people's class diagrams, but we probably won't be using it too much this semester. Okay, so if you want, I'll put this link in the description, and you can maybe go through the rest and see what other relationships that there are, but for now I'm just going to leave it there to keep the video nice and short. Okay, so that's everything for the video. Thanks for watching.